Hello, this is my Project 3 video for Mr. Osway's class. We're going to be looking at the flow around a cylinder. We're going to design right now really quick just, the circle, because it's like a cut, a cross section of it. So we're just draw a circle, and then we're going to draw a rectangle around the circle, a really big rectangle, to kind of show the area in the middle. That is what we care about, is all that space. So let's just start by sketching here. Let's start with the circle, our most important key player of this whole thing. And let's give it a nice little dimension of 1 meter. Let's zoom in on this. There we go. Now we draw 2 lines from the center, and we dimension those 2 lines. There we go. Now we can give the dimensions. So we want it to be like 50 by 50, like a nice square. So we'll do 25 for each of these. Then we can zoom out more because now they're big. And go back to draw, get a rectangle, just draw the rectangle like that, it doesn't really matter. Go to the constraints page, midpoint, both of these, just like that. And then we're left with that. Very cool. We can click this, we delete those now. We don't need those lines anymore. Now we have this. Concept, sketches, we click our sketch, and we can generate that now. And there is our surface. That's like the easiest part. Now let's move on to the mesh. Now there's one part in this mesh that will take a minute, but we'll get there when we get there. Otherwise, the mesh looks really cool. It's a really cool looking mesh. If only it would open. There we go. But listen to me. It heard. Okay. Let's begin. Insert. We're doing a method mesh to start it off. That is our geometry. And we're going to make it a triangle mesh. And we can start generating that real quick. Right quick. Perfect. Now the next mesh we need is a sizing mesh, which will happen in the center over here. We click edges, click that edge, we can apply it. It's going to be a number of divisions. Do 200, lots of them. You see them there, a lot of them. Now, no, do not capture curvature. Behavior, hard. And that should be good. Generate that. Perfect. Now, looks like this. Very cool. One more now we have to do. We have the inflation. Gonna click the base. For the boundary, it's this wall here. We can apply that. Now we have to make this, here it is, its first layer thickness 0.003, and the number of layers 65. Right there. And we can start generating that. And we can zoom out and look at it. Boom. Now the last thing we do here is the element size. We're going to do 0.2. Now we're going to generate, and this is the one that's going to take a minute. Just a little minute. So, I hope everybody's doing well. Hope so, yeah. Anybody got pets at home? I don't know. Oh, it's done. Beautiful. This is why I think this mesh is the coolest looking. It's because of the way it turns out at the end. I think this is insane. Just like crazy. Actually insane. It's really cool. Anyways, that's what we need to do. We can leave this after we name everything. then here and here we have tree symmetry. I spelled that right. Yep. And right in the center we have the wall. We have all of them. That's that part done. Now we go to the most. I just opened that on accident. I meant to update this first. There we go. Perfect. Now we can open this setup. Double precision, and the calculation is gonna take a minute in this one, so we're gonna do 4 of the solver processes. We can start that. Perfect. And now we can actually close these. We don't need these either anymore. Those are not needed. All we need is this now. I didn't have to use the results one. I kind of just, because everything in the results portion of the program is also in this, or at least the majority of it. Not like the charts and stuff like that you can do, but you don't need the charts for this one, because you're only being asked for the pressure, velocity, contours, and then the streamlines, which you can all get from here. So it's like, yeah, I mean, I'm just gonna do them here. So first case we need to do InVisit. So I'm gonna set that there. Okay, that's kind of all you need to do, because you don't need to tweak the material that you're using. You can just leave it as is and just work around that, or you can tweak that directly. It really depends. But for the boundaries though, now this always needs to be tweaked. You need to give it some kind of velocity to go in. We're gonna do 5 meters per second for the first case. And when you click on the wall, it shouldn't even let you edit it in any way. It should just be blank, yeah. That's just how it works with the InVisit. So now we can go to the initialization here, more settings, and we can give this more iterations than 10. Apply that, and then we can initialize it. There we go. Oh, we can go run the calculation. Now this calculation is going to take a minute. I'm gonna do less than I did for the actual report, but you know, I'll still do a good amount so we get some good looking results. 500 sounds good, honestly. So, oh, calculation complete. Because like that cut, it's like it happened instantly. You know, it's crazy. Anyways, now they've done that calculation in this same space, like I said before, we can just get all the contours that we need. So for the first one, the velocity one, interior surface body, node values, we can turn that off, and we can save display. So here is going to be our contours for the velocity. There it is. This is how it's honestly really cool looking, how it looks. But yeah, start the cylinder at 5 meters per second. Pretty cool. Then you can also just right here swap it to the pressure one that you need. Static pressure, nodes, same thing. Boom. And then you get the static pressure ones, and you get these little like clouds here to show kind of like, I don't know, I think I really like the way it looks in this program. It's cool. You can just tell that that's the wall right there, and then that's the patterns that they make. And you zoom in, you can tell the patterns even better. And then the last one, the coolest one, I would say, the path lines. So here's how you do it. We need it to be the velocity inlet, and we need the velocity, kilowatt velocity. That's fine on the steps. Yeah, I think that's good and safe. Now this one's cool. So it looks like that, but you zoom in and you notice it's just a bunch of lines showcasing the path lines that it takes, which is really cool. I think this is very cool. But yeah, regardless, that's how you get both those things. So now we can move on to how I was able to, because in the report, you're supposed to also get the velocity variations and the pressure variations, and then also get the drag coefficients for each case. So let's get those really quick. For what I did is I'd go to XY plot, so you can get all the variations of all of them. I would go right to file. I'd click, y-axis, it'd be velocity magnitude, and on the x-axis it'd be the curve length, and then you click wall, and then you'd write, and then it would ask you to write the name of the file. You save all these files for each case. You do XY for velocity, and then you do this XY thing again, but this time you do it for pressure, and you do it for pressure coefficient. And curve length, wall, write to file. You make more files. And I would just get all these files. I went to Excel, or sorry, not Excel, Google Sheets, and I would just make it on Google Sheets. I would put the things together and then add all the columns, put them into a chart. That's how I got my results. I'm not going to do that for the video because that would actually take way longer, but that's how I did it. So we're just going to close it here, but it is right here. It's in plots, XY plot. Now, what we will do, I will show, is how to get the drag force. So you click wall and you print it, and you get it right at the bottom, just like that. Now, let's move on to the next model. So let's edit things now. So for the viscous, we want it to be laminar. Perfect. Don't have to change the materials. Now we do have to change the boundary conditions though. So the velocity inlet, the speed's going to change. It won't be 5 anymore. We're going to make it 0.5. We're going to apply that now and close this. And for the wall, now we should have the settings, but all we have to make sure is we put no slip. Everything else is fine. Apply and close. We don't need to change any other values. All those values are good. All we need to do now is initialize this, which just saves our settings from before. Yeah. Should be 25. And then go to the calculation, should still be 500, and let's just run it. I'll see you guys after this, because it will, again, take a long time. Okay, the calculation just finished. So now that our calculation is finished, we are going to go back to look at our contours. It does save the settings that we had it on, but we will just do this really quick. Put it back to pressure. We'll do the velocity one first. I don't want to do the pressure one. Let me save this way. There you go. So that is the laminar one. Much different. The way that you can just tell how the velocity is going and the patterns of it, of everything. It's really cool looking. And there we go. Now let's do pressure. Pressure contour, safe display. Pretty similar to that. Not the same stream, but same thing with the pressure going on. And then the drops of pressure going on over here. Now, we have both of those. We can look at the path lines. So we only need to look at the velocity path lines. And for this case, they look pretty cool. Just like that. Going right around the cylinder and the path lines that it makes around it. Very cool. Okay, now that we've seen all of that, again, same thing. To get the data, I'll just do XY, but we will see what the force report looks like for this one. There we go, 0.16. Now, on to the last one. The model, change it back. We're going to go to K omega for our turbulent viscosity. Okay, I was looking at the settings, see everything was right. That also look good. We don't need to change materials. The boundary conditions we do need to change. So the velocity inlet, we're going to increase it now. We had done it 5, then 0.5. It's going to be 8. That's 8 now. And these 5 and 10, these are all fine. This turbulence settings are fine. The wall doesn't matter if it's no slip or not. It's fine just like that. And now we've done that, we can go initialize. Go ahead. And then we can run the calculation for this one. This one will also take a minute as well. So we'll be back shortly. So now that the calculation is complete, we can do the same thing and we can view those same things really quick. So we go back to the contours, look at the velocity one first. Now we can see what the turbulent one looks like. There we go. Oh, that's happening in the back. Pretty cool one, if I do say so. Pretty cool looking. And now we can go to the pressure one. It's kind of hard to tell where the colors are changing here, but they are changing, and there are like lines pathing different colors. I don't know how well it can tell in the video, but I see it pretty alright. And then for the path lines now, what is that? Now there's the turbulent for the path lines. Now it looks just like that. Zoom in. There you go. And again, XY plot for each of those velocity variations, coefficient of pressure variations. And now for the last part, the reports. Go back to forces, the wall, and we can print to get our number of drag. So that's the whole project and how you get your different cases. I hope that did what it needed to do. And that's all.